One of the things we like to talk about when we're looking at polynomial functions and their graphs is their end behavior. That's one of the things we like to ask about in terms of how do I describe what this graph looks like. And when I'm looking at polynomial graphs, um, it can be easy to get this mixed up with something else that we've talked about, which was intervals of increase and decrease. Intervals of increase and decrease are like I have a little guy walking on top of this graph, and we always read from left to right and say, what's he doing first? Well, he's going downhill, so that's decrease. And then he's increasing from here to here, and he's decreasing again from here to here, and so on. This is not that. We're not talking about intervals of increase and decrease. End behavior seems very similar to that, but is actually very different. So let's look at what end behavior actually is. End behavior is actually literally just asking what is happening at the arrows, basically. Like we like to draw arrows on a graph when we graph something by hand. It's basically asking which way those arrows are pointing. So really, end behavior is something that you could ask your kindergarten nephew, and he would do just a perfectly fine job of telling you. If I said, which way are the arrows on this graph pointing? Which way is the one on the left pointing? Up. Which way is the one on the right pointing? Up. Great. That's all end behavior is about, is literally what is happening at the ends of the graph. So there's a couple of things that make it not something that you could have done in kindergarten, something that you had to be a little bit more mature and sophisticated in your math abilities to do. One is that we don't just say up and left and right and down and words like that. We use math terminology, we use mathematical expressions to describe what's happening where. The other thing is that you are usually asked, or sometimes asked, very often asked, to tell what's happening with these things without being able to look at the graph, just looking, for instance, at the equations. So that I look at the equation and I'm supposed to be able to tell just from looking at, for instance, this equation, which direction the ends are going to point. Or looking at this equation, which direction the ends are going to point. Well, we talked about in class, we had a little chart, and it's not quite like that. It's a little bit more like this. That if we have, let's see if we can see that chart a little bit better. There we go, right there. It has to do with two things. In here is the degree. If the degree of my polynomial is even, then it's kind of like a parabola. Both ends are going to point up or both ends are going to point down. And it makes sense that that would go with a parabola because a parabola has a degree of 2, which is an even number. If the degree is odd, that's more like a line, which has a degree, a linear equation has a degree of 1, x to the first. They point in two different directions. If I have a line, one side points up when the other one points down, and or vice versa, unless it's horizontal, but we're not worried about that. So anything that has an odd degree is going to work kind of like a line where one side points up and one side points down. Anything that has an even degree is going to work out just like a parabola, where both sides point in the same direction, either up or down. The next thing we look at is the leading coefficient. That's what this is saying. The leading coefficient, remember, is the number out in front of your biggest degree variable. So for instance, if your degree was third degree polynomial, that would be the number out in front of x to the third. If your degree is, your leading coefficient is positive, then those two sides that point the same way both point up. If your degree is negative, and that's what this means, they both point down. Just like a parabola. If I have a parabola, it has an even degree. If it has a positive out front, both sides point up. If it has a negative out front, both sides point down. Same thing works with a line analogy over here for the odd degree. If I have a line with a positive slope, the left-hand side points down and the right-hand side points up. If my line has a negative slope, that would mean a negative leading coefficient, the left is pointing up and the right is pointing down. So using those things, and I like to remember in terms of comparing them to a parabola or a line, using the things from that chart, we can figure out the end behavior of pretty much any equation we might have. So for instance, on this one, I have a odd degree because it's a fifth degree polynomial. So that means that the two sides won't match. One will point up and one will point down. Figuring out which one happens, I look right here for my leading coefficient. My leading coefficient here is 1. It's positive. So that means just like a line with a positive slope, the left-hand side is going to point down and it's going to go up to the right. Now, it may not look like a line we might be talking about something more like this, and that's what a lot of, let's say, this is kind of challenging. I do not have a tablet, so let's say this could be something like that. Blah, 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 going after that. Okay, because it has a degree of 3, one side's pointing up and one side's pointing down, they're not pointing in the same direction, and because it has a leading coefficient that's positive, it starts low and ends up high. If I put a negative here, well then that would make me completely change things. Now it would look something more like this. Start high and end low, so go up on the left and down on the right. So that's how I can figure out which way it's going to look just from looking at the equations. Now the next thing is looking at how I actually describe, and I think I can go back here, but how I describe my end behavior. Let's see. And basically what this is through use of infinity symbols. And that's what makes it a little bit different. Let's look at this. This is a good example. Okay, this is actually a nice chart. Basically, if you memorized this chart, you would be good. But you don't really have to memorize it if you understand what it means. Okay, so let's see if I can. I'm going to borrow that. I'm going to take it over here. And play with it right here. So let's say I'm looking at a positive leading coefficient and an even degree. It looks like a parabola on the sides in terms of just the ends of the arrows. The first thing I want to look at here is these. You will notice, whoa, sorry, maybe it would be better if I highlighted. You'll notice that you're going to see the same two expressions with x on every single one of these, regardless of whether they're both opening up, both opening down, one up, one down, whatever. You're going to see the exact same two expressions for x every single time. And this is why. One of them, this one right here, means left. If you think about your graph, your basic coordinate plane, if you were to go all the way to the left of the x-axis and keep going forever, basically in terms of x you would go to negative infinity. So another way of saying on the left is to say that x is approaching negative infinity. That's all this means, is this says on the left. This is just a mathematical way of saying on the left. And likewise, if you go all the way to the right, then you're approaching positive infinity. So this is just a mathematical way of saying on the right. So on all of these, if we want to tell the end behavior, we want to tell what's happening on both ends. So it will say on the left and on the right. We're going to do both sides. So every single time you're going to see x approaches negative infinity and x approaches positive infinity, usually with the word as in front of them. As x approaches negative infinity. As x approaches positive infinity. Because we're saying as we go to this side of the graph, and then we talk about whether it's going to point up, our graph is going to point up or down. And as we look toward this side of the graph, and we get closer and closer to this side of the graph, we think about whether it's pointing up or down. Now that's the next part. And that's where this particular chart is a fail, is because sometimes we'll say y, yes, but more often we'll say f of x. So instead of a y here, usually this would be an f of x. Okay? F of x approaches positive infinity means it's pointing upward. F of x approaches negative infinity means my arrow is pointing downward. So after you've said left and right, then you have to say what's happening on the left and what's happening on the right. So this says on the left, my graph is pointing up. And this says on the right, my graph is pointing up. Because both of those say y approaches positive infinity. So as long as you just substituted an f of x for that y, you would have the way we normally do that. This one says on the left, My y values are pointing down. My arrow is pointing down. So that's what this is saying. Down. Sometimes it's easier to do cursive on this. It's kind of a fail this time. And this one's saying on the right, my arrow is pointing up. Okay, the right is this part right here, saying that x is approaching positive infinity because that's the right. And this part here saying y is approaching positive infinity says it points up on the right. And so on. This says, the green part says on the left, the unhighlighted part says f of x is approaching negative infinity, says it's pointing down. On the right, it's pointing up. This is just me putting into words what the math symbols are telling me. On the left, this one points up. On the right, this one points down. So that's how the terminology works. It's not particularly scary. Seems it at first, maybe. But so, for instance, let's see what we can do here. Let's say I have just an example. I'm going to do all right. I don't like that as well. Let's go with there we go. Make it pretty. I'm going to zoom out. And of course, I don't have arrows here. So I have to imagine them. And in imagining my arrows, let me clear this page. I'm going to imagine an arrow right here. I'm going to imagine an arrow right here. Okay, so on the left-hand side, this is pointing up. On the right side, it's pointing down. So let's say left, and that's typing in white, so that's not very helpful. There we go. On the left, it's pointing up, and on, whoa. Still true, so we're going to keep going with it. It's interesting that it keeps zooming me in. Ah, the joys of technology. I get it sooner or later. There we go. On the right, it points down. Now let's see if I can zoom back out. Ta-da! Close enough. Zoom in a little bit and over. There we go. So we have on the left, it's pointing up, and on the right, it's pointing down. So let's figure out how we actually need to write that in terms of math. On the left means as x approaches negative infinity. And really, again, I should have the word as. As x approaches negative infinity, comma, f of x, which way is it pointing? Is it pointing up or down? It's pointing up, so we would say approaches positive infinity. Right is always described by x approaching positive infinity. And again, I left out my word as, sorry. As x is approaching positive infinity, f of x, it's pointing down, so I say it approaches negative infinity. And that is how I describe my end behavior. Voila.